So let's get started in handling these exceptions. In Java, there's a convenient way, which is called a try-catch block. Basically, try something. If any of that part throws an exception, we will catch it and we will do something with it or deal with it, let's say. So how would this work? So let's say over here, we could see our exception is going to be thrown by our scanner here. First thing first, we're going to take off this throws and we're going to be the one that deals or handles this exception. So what we need to do is the part that's we want to, the block of code that would, let's say, let me rephrase this. The block of code that would throw an exception, we want to put it inside our try. Basically, if one part of that fails, we don't want it to continue in that block. So what does that mean? So let's say over here, really this is the part that throws an exception. So if we want to, we could say try. Actually, I'll put my curlies here. We're going to try this scanner. And if it breaks, we're going to catch it. And what type of error we're going to catch? Well, it's going to be that exception that's being specified. File, not found, exception. And we could write, so this is a type, and we're creating a variable for that exception to come in there. So we're going to just type in exception here for now. So you could see now the error is gone. The compiler error saying you're not taking care of this exception. To be honest, we're not really taking care of the exception because the catch is empty. Okay. The second problem, we're going to fix this soon, but the second problem is now that this scanner is inside this context block, inside this try block, it's not visible after the block, right? We talk about context. The moment you create something inside curly braces, it only lives as much as the curly brace. So if we scroll down, you'll notice that the scanner here does not exist anymore because it ended the moment it reached here. So in this case, the try has to include everything that has to do with that scanner. So over here, we're going to grab this, cut it out, and put it in here. Let me actually close this. So you'll notice that now the scanner exists because we're in the current context. We could have also put this file inside the try, and that would be fine too, even though the file does not throw that exception. We could do a control Q to see what exception it throws. You could see here from the documentation, the file will throw a null pointer exception if the path name argument is null. Okay, we'll deal with that a bit later. So over here, we specified a file name, and if it throws an error, you remember we saw it inside our runtime or our execution of the application. We could see there's an exception here. But this time, if we run it, and you could see the stack and all that stuff, we run it, if it throws an error, we'll catch it, and the user will never see it. I did catch it. The user's application did not crash, but to be honest, it didn't do what it should have been done either way. So this catch is not that good. Inside the catch, we have something that's interesting. The exception class gives us 3 methods that's really useful to us, and a bit of other stuff. But these 3 methods, the first one is called getMessage. Oops, I pressed the wrong button. GetMessage gives us the message that comes with this this exception. So if we do Control Q, returns a detailed message string of this throwable, and we could see that it's of type string, and that's the method call. So if we wanted to, we could do a system.out and put that exception so that the user could see it maybe. For now, we're just gonna run it, and you could see over here, this file, see whatever, the system cannot find the path specified. So this thing just doesn't exist. Let's try maybe a file that's just here. So rather than using this full path, we're going to utilize a file that's already here. We have OOP IML, which is this stuff. We could create another one. Let's go ahead. and we're just going to create a file. Let's say input. I should have probably typed in the type. Refactor, rename, input.txt. Who cares? Yes, do refactor. Okay. Actually, this shouldn't be in the source. Sorry. We're going to put it right beside here. Why am I putting this? It's a relative path. We'll talk about pathing a bit later. But for now, notice there's an input.txt, and we're going to put some values, 34, and maybe something else. Okay. Let's go back to our file basics. Okay. Press the wrong thing. And in this case, rather than saying C colon and all this stuff, we're just going to say the relative path, in this case, input.txt. Okay. So now if I run it, hopefully I didn't forget to do something. Notice that our error, enter an integer, we got a different type of exception, which says input mismatch exception. So we actually fixed this error, right? Let's go back to having that normal thing, and we run it. Just so we analyze this, and rewind, go forward, pause the video, make sure it makes sense. You could even write this down yourself. So this file cannot be specified. This file cannot be found, right? And we allow the user to get a better error message so he could figure things out. Now, if we want to deal with this a bit better, what we could do is we first create a scanner. I'm going to show you I want to show you a couple things, okay? Actually, before we do that scanner, I forgot some stuff I wanted to tell you. The first thing is inside this try block, the moment an exception happens, the block will end. So in this case, we got an error at this line that says scanner file. The moment this error happened, it never reached line 14 or 14 to 22, it never reached. It directly jumped from line 12, from this line, to our catch. So what does that mean to us? So let's go add some system.out before scanner, system.out after scanner, right? Pretty straightforward. Here we're going to put inside catch. And here we're going to say one last one, outside try catch. Now, when we run this application, notice we get before our scanner, this is the line that ran. Then this line, the scanner got an error. So we don't see after scanner, we only see inside catch. So it skips everything else inside the try, directly goes to the catch, does whatever's in the catch, and when the catch is finished, we go outside of our try catch. So this try catch is completely done. That's why you see outside try catch. So our application doesn't exist. This is what's so good about handling our exception. But again, you got to understand that the try block is made so that the moment an error happens, it will not continue. So if you wanted something in there to be done, well, you got to make sure it's outside the try block. Now, let's make this a bit more interesting. We're going to create a scanner, user scanner, and it's going to take a new scanner, and it's going to take system.in. From this user scanner, we're going to ask the user for a file. Please enter a file name, right? And the user enters a file name, so string file name equals user scanner next line. So rather than here putting this value that we see here, we're going to ask the user for a file name. It gives us a file name, and the rest will continue as is. So here, I enter a random file name, we get the same thing as we did before, right? I'm going to take off this before and after stuff so our console screen is not too polluted. You could try that out with those little trace messages. So again, error. So asta is not something that exists. So now we could make this message a bit better, right? For now, this is not so bad, but we could improve it in a bit later. What else can we do? If our application ends, it's not so good, right? Because that's not the point of our application. It doesn't just give an error and then exit. We have to kind of tell the user what's the problem. So we could say something like this. File not found. Please try again. And maybe I'll put this one first. And put all of that inside of a do while. Or a while loop, whichever one works for you. Or an infinite loop, whatever works for you. Right? And we're going to put all of that inside of that. So while this is true, we're going to do all of this. And the moment that file exists, we could do the rest of it and then do a little break. What is the break going to do? It's going to break from that while true. We got an error here. Unreachable statement. Why is it unreachable? Oh, because we have another while true here. Okay, that we'll manage. We'll manage that in a second. You know what? Let's just put a break here. Okay. I don't even know what this while true was for. Oh, it was the errors that we did. So too many integers, but our array only has of size 3. While position is less than, let's say, my array dot length. So we don't need that little break over here. There we go. Okay, so let's run it again. Let's see what happens. Please enter a file name. I enter something stupid. It tells me that file cannot be found. So we could try again. Please enter a file name. Now, if I put in input, it probably is going to give me the same error. We need to put in input with the extension. So input.txt. And you could notice that we get a different type of error. What is the error that we're getting? So notice that in this case, before we talk about this error, notice that this case, we keep asking the user, right? We keep inside this while true. We keep asking the user for the file name, for the correct file name. And whenever it's wrong, we tell them, hey, it's wrong. And then the loop tries again until it gets it. So this is a really nice, cleaner way of managing our, in this case, the file doesn't exist. So it doesn't crash our application and it continues. So coming back to this, when we ran it this time, our catch was good. It dealt with the file not found exception, but we got another exception in there. Notice we got an input mismatch exception. Again, something that was an unchecked exception. Where is it coming from? We look at our stack over here, and we could see the blue one. That's the important part. The gray ones are not our code. The blue one says at runtime errors.java, that's my file, at line 23. So if we look at line 23, at some point it got to trying to find the integer, but it couldn't find it. Let's go look at our inputs.txt. We got integer, integer, and then a string. If you notice here, we got enter an integer. We got the first one, 23. Enter an integer, got the next one, 34. And then enter an integer, we got a word. Now, this is the cool part. This catch deals with file not found, but we could also deal with a different catch. In this case, input mismatch exception. Again, we give a name for that variable. It could be any name we want. It's a new stack. If you look over here, I'm going to just put an extra line. So not a new stack, a new context, a new body. So this variable exists only in this body. And this variable, which is named the same thing, is only going to live inside this body, this context. But the types are different. And in this case, we could again say something else. Well, first of all, let's go get the message. Let's see what it says. And then say, I don't know, let's just see what the message says. So we run it again. Input.txt. And look what we got. This message is not so good. The get message would just give me null, which is not good enough. So this message is not good enough. But the exception method, the exception class, we said gives us a couple things that are interesting. The first one was get message. The second one is get the cause. What was the problem? Now, this is not always good because it's only good when they let us know what actually caused this issue. So we could run it and see. Most of the times this is not being handled, so sometimes it's nothing in there. We're going to see in a second. And again, you could see that it didn't give us much more information. So in this case, we know what the problem is, input mismatch, because we know that only one place will throw this next int over here. And it's going to throw this input mismatch if the next int token does not match the integer regulation. So here we could say input, not input, it's from the file. So let's say file contains non-integer values, and that's good enough. So let's rerun it. Input.txt, and this enter integer is this line over here. We could even we could remove it. We don't need it anymore, right? Let's do it one more time just so it's cleaner. Input.txt, file contains non-integer value. Please enter another file. So you see here we had two types of exception. One where was the file not found, and another where the file was found but it contained wrong stuff than what we needed. Cool. So this is the same try block, but two different catches. Now, if we wanted to, we could actually catch both of these types of exceptions with one catch. Is it good or not? It's based on what you're going to do in the catch. If it's the same thing you're going to do for the catch, well, it's perfectly fine to catch both of them. And you got to remember that these catches, they're kind of like an if else. What that means is that the first catch, if it catches both errors, well, then it's going to go in that catch. Otherwise, it's going to go to the next case and check if that's true. And that being this little parentheses over here. What does that mean? Well, one way to catch both of them is to put the higher class in there. So the class that these two are deriving from, and we saw that in the last video. And we could just say, if they're deriving from exception, which basically captures everything, catch it and do something with it. And you're going to see there's already a warning coming up. I'm going to explain it to you in a second. First, let's do all errors are caught here. Now, we're getting a compiler or IDE error, whichever one you want to call it. And the problem is, because we catch everything here, it's impossible for these to ever run. And that's what the error is. Let's see if I can run it, even though it shows me an error. Most likely won't allow me to. Yeah. So the problem here is if we look at this message, it says that the file not found exception and also the input mismatch exception has already been caught. Again, remember the hierarchy. It goes from top to bottom. It goes from line 28, then to line 31, and so forth, so on. So if this one is true, there's no reason to continue downwards. It will automatically break it, do this part, and ignore these. But this will catch all exceptions. However, this is a bad thing to do because you're catching all exceptions. What I mean by that? Well, over here, we're catching file not found exception, and over here, we're catching input mismatch exception. They're specific to the problem. But if we look at next int and do control Q again, you'll notice that it doesn't only throw one exception, in this case, input mismatch. It also throws two other exceptions. No such element exception if input is exhausted. Illegal state exception if the scanner is closed. We're not going to throw these, but the point of this exception over here is capturing other types of errors even though we didn't handle them. So we might be doing something unexpected by catching everything. The same thing, a great example would be fishers. Inside our oceans, there are some fish that helps other things. So there's a lot of rules to make sure that we don't catch fish that would destroy our sea environment. Let's say, like an example, we're not supposed to catch whales, right? They're fundamental for our oceans to thrive and be a living thing. So what they do is when they put those big nets, they got to make sure that those big nets cannot catch those whales. If it does, well, we're going to eventually kill off all our whales, right? They cannot catch every type of fish with those nets. Otherwise, there will be issues. This is the same thing. If we catch every type of exception, we are going to cause some issues in the long run. So this is a bad way. So how can we catch more than one exception rather than catching everything? One thing we could do, let's say over here in the next int again, we want to catch no such element exception or illegal state exception. These two other ones that next int could throw at us. So what we do is we specify them, no such element exception and illegal state exception over here. No such element, you could see there's a lot of exceptions. And if we want to catch more than one, we're going to do this pipe, this thing that's on top of your enter keyword, should be around there. All right, this is the same thing as the or, but only one of this. And we said illegal state exception. So here we're going to type in illegal state exception. Now, by doing these two, we're only catching these specific ones and none of the other ones. We'll notice we got an error here. We're going to put our mouse over it. So here we got a problem where it says input mismatch is already caught. Why is it cut? Because it extends, and again, we're going to talk about this a bit later. No such element exception. And I'm guessing one of these, here we go. Because this one extends no such element, this is inheritance, we'll talk about it later. This is already being catched. So this one is already being catched here. So this is not a good one. I'm just going to erase it. But this is the way to catch two things at a time, right? And if I want more, just add more pipes and specify something else, maybe this one. Cool. And if you specify an exception that's not being thrown in here, again, the compiler will give you some warnings or errors. But this is the way to catch multiple exceptions if you want. The other way would be for inheritance. And we'll see that after inheritance. If I remember, if I don't, you saw it by doing exception. Actually, I'll show it to you inside the assignment labs. So this is the initial way of handling exceptions. And we're just going to run it just to make sure it works. Input.txt. File contains non-integer. Put some other one. Let's say, let's go ahead and just change the value here to 43. And I put input.txt again, but the file has been changed. Everything works well. The application ends correctly. We're good to go. So in this one, we handled exceptions. This is how we handle them with try and many catch blocks. Remember that our try block will end the moment a catch happens, the moment an exception is thrown. So we deal with it, and we could come back to this code with a while true or with some loop or with some whatever type of code you have to come back to dealing with it. Don't do nothing like as in don't catch it and just don't do anything. You need to give feedback always. And don't throw it outside, as we've seen with the signature. In the next video, we'll continue the catch block. See you guys then.